Here's a quick walkthrough on how to solve trigonometric equations. In these questions, I'm trying to find all values for the angle between 0 and 2 pi that will actually work out. For this first example, we could start by subtracting 1 from both sides, which would get us closer to getting the sine by itself. And then dividing both sides by 8 brings us to this point. The sine of theta is equal to negative 1/2. Now, at this point right here, there's two ways to go. You could either go based on your memory or based on using the graphing calculator. Since many students are still remembering and being refreshed about what these angles do produce, let's use the graphing calculator to actually get the angle. So we're going to press second and then the sine button to get my arc sine command, the inverse sine, and then just type in negative 1/2, and it will give me my angle measurement. So the calculator is telling me one of the angles is negative 30 degrees. What I'm going to do now is think about my unit circle to get the other angle, because there'll be more than one angle that will actually work for this equation. So I'll start by drawing a unit circle, and I'll draw on the angle negative 30 degrees that the calculator told me would work. Now, more officially, that angle would be a positive angle of 330 degrees. So that's going to be one of my answers. Now I need to come up with the other angle that would actually give me the same sine value. So, to do that, I need to think about what sine represents in the unit circle. Sine represents the y-coordinate. So I'm looking for the spot on the unit circle that has the same y-coordinate as this point right here. So the same y-coordinate means I just read across here, and I'm going to be using this point here on the circle to help me figure out the last angle. So go directly across, since we're looking for the same y value, and I need to find out what this angle was worth. With this being my terminal side. So this is 30 degrees going beneath the x-axis, so this would be altogether 180 plus another 30, which would bring me at 210 degrees for the second angle. As I mentioned, these answers are in degrees, but the calculate or the work that we're doing will ask you to write them in radian measure. So it's good to remember that 30 degrees is the same thing as pi over 6. So using that idea, we can quickly convert these even in our heads. So full 2 pi going around the circle twice will be worth 2 pi, or be worth 12/6. We're backing up just 1/6 of the way, so 11/6 pi would be 330 degrees. And then 210 is 180 degrees, which is 6/6 plus another 6 gives me 7/6 pi for the other angle. If you have to convert them by multiplying by pi over 180, that's fine too. But it's good to work on them in a quicker way like I just showed you. All right, here's two more examples. The next one has cosine, and we're going to begin this one by getting the cosine on one side. So we'll start by subtracting away a cosine from both sides of the equation. It'll give me 0 here, and for this part here, 3 cosines take away 1 cosine would be leaving me with 2 cosines. Plus that radical 3. Well, in 2 quick steps I can get the cosine by itself. subtract radical 3 from both sides, and divide by 2, gets my cosine curve isolated, or my cosine isolated. And then from there, it's using the graphing calculator to get the angle, or figuring it out based on your memory. So by using the inverse cosine command on the calculator, we can let the calculator give us one of the angles. It's telling me that the angle is worth 150 degrees. I'm looking for all angles that will work in a full circle. So I'm going to locate the first angle right off the bat at 150 degrees. And now I have to think about cosine. When we're talking about the cosine, we have to remember that the cosine represents the x-coordinate. So I need to find a point on that circle that has the same x-coordinate as the point that I've got right here. To do that, to have the same x-coordinate, it would have to be vertically below right here. So for cosine, I'm just going to draw that in. And that's the point that I'm going to focus in on. And I'm going to need to come up with how many degrees that's worth. Well, the first angle was 150 degrees, which is 30 degrees shy of 180. And since the circle's symmetric, I need to dive down another 30 degrees to get to this terminal side right here. So 150 degrees was the first angle, and 150 plus 180 plus another 30 would give me my other angle at 210. And then you can get those in terms of radians as well. So this would be 5 pi over 6, and this would be 6 pi over 6 plus another pi over 6 would be 7 pi over 6. And then one more to go. So on this one, it looks very similar to the other start. We've got tangents on both sides of the equation, so we can subtract a tangent from both sides. We also want to get the tangent by itself, so we can add 2 to both sides. So this can be all done in one step. Those cancel, and I get 2 tangents, theta equals 2. Well, one more quick move to get tangent by itself, divide both sides by 2, and I get the tangent of theta equals 1. Now you might know that by heart, what the angle is, but if you don't, you can always rely on the calculator to give you the angle by doing the inverse of tan of 1, and that would be 45 degrees. So now I'm going to think about my unit circle to try to get the other angle that would work out. So I'm getting 45 degrees is my first answer. Now I have to think about what tangent represents in a unit circle. Well, cosine represented the x, sine represented the y, tangent is sine over cosine, so it's y over x. So that means that tangent represents the slope. In the slope formula, it's y minus y over x minus x. So tangent is the slope of the terminal side. So in this case right here, to find the other angle, what I simply have to do is keep the same slope and just draw an extension of that terminal side across the circle, and that would be my final angle that I would need from here to here. So that's also 45 degrees here. These are vertical angles. So these angles will both be 45. So this angle right here is 180 degrees. 180 degrees plus another 45. So 225 degrees. So at the end I can write both of my answers, 45 degrees and 225. But if I want to express them as radian measure, the angle would be pi over 4, which is 45 degrees, and 225 degrees is 180 plus another pi over 4. So 4 pi over 4 plus pi over 4 would be 5 pi over 4. I hope this quick tutorial helps you. These are the answers to 3 of the questions from the homework, and good luck.